Discovery of proton. After discovery of canal rays, attempts were made to discover the lightest particle which carries a unit positive charge. Therefore, canal rays produced by using various gases were analyzed. And it was found that the lightest positive particle, having a unit positive charge, could be obtained by using hydrogen gas in the discharge tube. The value of E upon m for the constituent particles of hydrogen gas was found to be minimum. These particles possessed minimum mass and a unit positive charge. Determination of mass of these particles revealed that the mass of one particle was 1,837 times the mass of an electron. This particle was called proton. The presence of proton was further confirmed by radioactive disintegration. How are positive rays produced? When high-speed electrons, that is, cathode rays, strike a molecule of gas in the discharge tube, they knock out one or more electrons from it. Thus, a positive ion is formed. M plus E minus gives M plus 2E minus, or M plus Ne minus gives Mn plus and plus 1E minus. These positive ions pass through the perforated cathode and appear as positive rays when electric discharge is passed through the gas under high electric potential. The molecules are also dissociated into positive atoms, or ions that constitute the positive rays. E. Goldstein, 1896, discovered protons in the discharge tube, containing hydrogen gas. H2 gives 2H plus, that is, proton, plus 2E minus. Sir J. Thomson studied the nature of protons. He showed that a. the actual mass of proton is 1.672 into 10 raised to minus 2 per gram. Proton has mass of 1.00727 atomic mass unit, that is, AMU. B. The electrical charge of proton is equal in magnitude, but opposite in sign to that of the electron. Thus, proton carries a charge plus 1.60 into 10 minus 19 coulombs, or plus 1 elementary charge unit. Since proton was the lightest positive particle found in atomic beams found in the discharge tube, it was thought to be a unit present in all other atoms. Ernest Rutherford, in 1919, gave convincing proof of presence of proton in the nucleus. He bombarded atoms of nitrogen and aluminium bioparticles, and found protons were ejected. Neutrons are unstable outside the nucleus, and disintegrate into proton and electron. Protons were also obtained in a variety of nuclear reactions, confirming further that all atoms contain proton. Thus, a proton is defined as a subatomic particle which has mass of 0.00727 AMU, and charge plus 1 elementary charge unit. It is 1 unit mass numbers, and 1 unit positive charge. Discovery of neutrons, and constitution of atomic nucleus. In early days, only proton and electron were known as constituent particles of atom. Hence protons and electrons were called as subatomic particles. In an attempt to suggest the constituents of an atom, William Prout proposed that the atoms of the elements are made up of requisite numbers of units of hydrogen atoms. Assuming atomic mass of hydrogen atom as 1000, the atomic masses of all elements must be whole numbers. However, observed atomic masses of chlorine and copper were 35.5 and 63.5 respectively. Hence, Prout's theory was rejected. This rejection, however, was wrong. There was no knowledge of presence of two natural isotopes of chlorine and copper. According to Prout's theory, oxygen with atomic mass 16, nucleus must contain 16 protons, and there should be 16 extranuclear electrons. Similarly, helium must contain 4 protons in the nucleus and 4 extranuclear electrons. The observation showed that oxygen, helium, and almost all atoms of the elements contain almost half numbers of extranuclear electrons, as compared to the number predicted by Prout's theory. To account for the discrepancy, a new theory, proton-electron theory, was proposed. According to this theory, it was proposed that, apart from extranuclear electrons, some electrons are also present inside the nucleus. Observed emission of beta particle, that is electron from the nucleus, supported the hypothesis. The theory was called as proton-electron hypothesis. The proton-electron theory was rejected by Fermi. He proved that electron is too large to be accommodated in a small space of atomic nucleus of size 10⁻⁻⁻15 meter. The theory also could not explain spin of some nuclei and energies of beta particles emitted by radioactive nuclei. So as to overcome failure of proton-electron hypothesis, Rutherford in 1920 proposed the existence of a neutral particle made from close combination of proton and electron. He named it neutron. Neutron has no charge, and has mass almost equal to the mass of proton. Its existence was accepted by almost everybody, because it satisfied all characteristics of atomic nucleus, like mass, charge, spin, etc. However, neutron remained hypothetical particle, because it was neutral, and could not be deflected in electric and magnetic field. Lord Chadwick, in 1932, first proved existence of neutron. He bombarded lighter elements, like boron and beryllium, by alpha particles. Highly penetrating, neutral radiations were emitted. It was thought that these radiations must be gamma rays. But the radiations differed in interaction with hydrocarbons and with elements like helium, lithium, carbon, oxygen, nitrogen, etc. The nuclear reaction of alpha particle with boron and beryllium is as follows. B, that is boron, with atomic mass 11, and atomic number 5, plus He, that is helium, with atomic mass 4, and atomic number 2, which is alpha particle, gives nitrogen, with atomic mass 14, and atomic number 7, plus N, that is neutron, with atomic mass 1, and atomic number 0. Be, that is beryllium, with atomic mass 9, and atomic number 4, plus He, that is helium, with atomic mass 4, and atomic number 2, which is alpha particle, gives carbon, with atomic mass 12, and atomic number 6, plus N, that is neutron, with atomic mass 1, and atomic number 0. Neutron is denoted by small n, and in the place of atomic mass, we write 1, and in atomic number, we write 0. It is neutral in nature. Its mass is almost equal to mass of proton, as it is a close combination of proton and electron. Immediately in 1932, Heisenberg put forth proton-neutron hypothesis. According to this hypothesis, an element, X, A, Z, here, X has atomic number Z, and A, the mass number. The nucleus contains Z protons, and A minus Z neutrons, in nucleus, and there are Z extranuclear electrons revolving around the nucleus. Protons and neutrons are present in the nucleus. Hence, these particles are called nucleons. Protons, neutrons, and electrons are constituents of atoms, hence are called subatomic particles.